Hello and welcome to the BTI's high-throughput plant phenotyping facility. We're excited to provide you with a virtual tour that delves into the opportunities that BTI's facility provides by using cutting-edge imaging technologies, methods for evaluating plant growth, responses to environment, and supporting the groundbreaking research conducted at BTI and wider Cornell University campus. Located in the plant growth facilities area of the BTI, we have constructed a custom growth chamber where we're able to control photoperiod, light intensity, temperature, air humidity, and CO2 levels. The growth chamber has a space dedicated for growing plants that are positioned on the conveyor belts. The growth chamber can house up to 64 large plants such as beans or tomatoes, or up to 1,280 smaller plants such as Arabidopsis. The plants are positioned within the trays that have been specifically designed for the facility, that are equipped with an RFID tag that allows us to recognize each individual tray and the information related to plant genotype, treatment, age, specific imaging protocol. While the bottom of the tray is the same independent of the type of the plant we are growing, the top of the tray is interchangeable between Arabidopsis type tray and one plant per tray type. The top of the tray can be adjusted to fit a wide range of pot sizes through a 3D printed insert. Additionally, if we're working with plants that need to be spaced further from each other, we can also do it by installing a specific capacity of each belt that will increase the distance between individual plants to prevent shading. Between the imaging and watering grounds, the plants are typically hanging out on the conveyor belts under the growth lights. Wherever the specific imaging or watering round is scheduled, a series of conveyor belts and pushers are moving the trays around into a sluice and afterwards to an adaptation tunnel. The adaptation tunnel is equipped with exactly the same lights that we have above the growth area and allows us to adapt the plants to either light or dark conditions depending on a specific protocol selected to measure photosynthetic efficiency. Once the plants are sufficiently adapted, they are transported into a crop reporter imaging system that was produced by the Phenovation. Here, using multi-spectral camera, we are measuring chlorophyll fluorescence of the plants, as well as other parameters that reflect photosynthetic efficiency, non-photochemical quenching, chlorophyll, and anthocyanin indices. While the camera is taking only the images from the above, it can move over the Z-axis to adjust its position to be exactly 50 centimeters above each plant. So, in the next imaging station, the plant is being photographed from above and side with RGB cameras that are also housing a chlorophyll fluorescence camera. While we are not making any photosynthesis-related measurements here, we are using chlorophyll fluorescence to automatically mask each picture, which means extracting the pixels that belong to the plant from the background. In the RGB station, the tray is positioned on a turntable that allows us to image the tray from multiple angles, which is necessary to approximately estimate the digital plant biomass for plants with complex architecture. The images from RGB are automatically processed and the height of the plant is assigned to each tray, which will be then used for the next round by the crop reporter to adjust the height for its measurement. Once the plant enters the automated weighing and watering station, the tray ID informs the machine of the tray type, which will then position the tray either over the 1 weighing unit or the 5-fold weighing and watering unit. Each plant will be measured and watered depending on the experimental setup. Here we can water the plants either using absolute means, such as 20 milliliters of water per day, or based on the target weight that user selects for each plant, or based on the use of the water from the previous day, which might allow us to keep up with the water demand as the plant grows and needs increasingly more water. In the case of Arabidopsis trays, each pot is lifted individually by the embedded scales, and little watering and fertilizing guillotine is making sure to provide each individual pot with exact amount of water that is necessary. The little blue mats that we're placing above each plant are ensuring that the water is being distributed as equally as possible throughout the top of the pot, as well as prevent the soil particles from floating around and jamming the conveyor belts. The plant weight before and after watering is recorded for each plant and each watering round, which the researchers can use to calculate something called evapotranspiration, which is an estimation of how much water is being lost between each watering round due to water evaporation from the pot as well as plants transpiring the water as it grows. Once the phenotyping round is finished, the plants return to their original location on the buffer belt and wait there until the next imaging round is scheduled. Thank you so much for visiting our plant phenotyping facility today with us. If you're interested in more information or using the facility in the future, please reach out directly to me or Julie Bell from our greenhouse facilities. Bye!